Welcome to partial ionic character of covalent bonds. So remember that when atoms of different electronegativities react to form molecules, the electrons are not shared equally. Right? They're only shared equally if the two atoms are identical elements, because in that case the electronegativity will be the same. But if the electronegativities are different, then we get a polar bond. And so we can calculate the percent ionic character of a bond. So how polar the bond is, basically. What percentage of it is like an ionic bond. So we can get the percent ionic character of the bond is equal to the measured dipole moment of x minus of xy, that covalent bond, divided by the calculated dipole moment of x plus and y minus what it would be if they were an ionic bond, and then multiplied by 100%. So with an ionic bond, this value is going to be either 100% or really close to it. With a nonpolar bond, a totally nonpolar bond, it's going to be 0%. So something like hydrogen bond, it's going to be this value will be 0. And something in between, say a hydrogen-oxygen bond, will be something in between. It will be, 10% maybe, something like that. So here you see some percent ionic character as a function of the electronegativity difference between the two atoms. So if we have something like iodine and bromine, those are fairly similar in terms of electronegativities, which means that the percent ionic character is fairly low. So the electronegativity, the difference there is around 0.3, so the percent ionic character is quite low. For something like hydrogen fluoride, the percent ionic character is maybe 40-45%, something like that. And there, the electronegativity difference is fairly high. It's around 1.8. But these, you notice, these are all covalent compounds. Now, hydrogen fluoride is really quite polar. But then you see over here something like sodium chloride, potassium chloride, lithium fluoride. These things have a very high electronegativity difference. And their percent ionic character, it's not 100%, but it's close to it. It's, upwards of 70-75%. And so these we classify as ionic compounds, and these we classify as covalent compounds. And so note that as the electronegativity difference increases, the percent ionic character increases, but none of the compounds are really achieving 100% of the ionic character. So none of them are really totally ionic. There's always a little bit of sort of sharing that goes on, in that it's never, the bond is never quite as ionic as what theoretically it ought to be. So note that these results are for the gas phase, where the existence of separate ions is stabilized. For a solid phase, and where each ion is surrounded by ions of the opposite charge. So instead of paired together in a molecule with a neutral charge. So to avoid having to go through all of this this calculation, we generally use this definition as for an ionic compound. A compound that conducts electric current when melted, we classify as ionic. If it doesn't conduct electricity, or an electric current when it's melted, then we classify it as not ionic. It's a covalent compound. So something like sodium chloride conducts electricity, so we classify that as ionic. So that was partial ionic character of covalent bonds.